Hello guys, how are you today? Today I'll be explaining the chapter 2, 2.1 and 2.2 course questions. I said in the 2.1 course practice we have until question 10. لأنه this is where 2.2.2 stops. But I asked my teacher and my teacher said that we have until question 12. Okay? We'll be solving everything and hopefully it will be a smooth video and hopefully it will not take too long. Also, I do apologize if my voice is a bit unclear because I got a cold sadly, and so I'll try to make the best out of my voice to make it a bit clear. So let's start. Evaluate 20 factorial over 4 factorial times 16 factorial. Which is closer to 20? Is 4 closer to 20 or is 16 closer to 20? Definitely 16 is closer to 20. So what are we gonna do? We are gonna multiply starting from 20 all the way to 16. So 20 times 19 times 18 times 17 times 16. We stop because this is what we need. Then we put factorial after 16, right? Now, over 4 factorial times 16 factorial. What do we have in common? We have this and this in common. We can erase them. Okay? And now we will be left with what? With 20 times 19 times 18 times 17 over 4 factorial. Just put it on the calculator. And you are supposed to get an answer which is what? Which is 4,845. So that's the answer for question number 1. Let's move on to question number 2. How many 4-digit odd numbers are there? So look how they did this. They said, okay, we need a 4-digit odd number. How many digits? 4 digits. So you do 1, 2, 3, and 4. When they say odd number, always the last digit should be odd. And these, they don't really matter. As long as the last digit is odd, that means the whole number is odd. And the numbers that are before the odd digit really do not matter if they're odd or even or whatever. Now, we start with the very first digit over here. Very first digit cannot be 0. So that means instead of being a number from 0 to 9, it will be what? It will be a number from 1 to 9. And how many numbers do we have in between 1 to 9? We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Exactly 9 digits. So how many digits can be in the first one? The first one can never be 0. So it can be any number in between 1 to 9, but it cannot be 0. So that means it's gonna be 9. Why? The digit, is not 9, but it's 9 because we have 9 possible numbers to put in this over here. Now, for the next one, this one over here, it is in the middle, right? So it can be what? It can be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it can be from 0 until 9. How many digits do we have from 0 until 9? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 possible digits that can be placed in what? In the second. Same thing for the third. You can place from 0 to 9. So the condition for the first one is that it cannot be 0. That means we have 9 possible numbers. For the second and third one, you can put any of the numbers from 0 till 9. That means we have 10 possible numbers. And for the last one, it must be odd. What are the odd numbers from 0 until 9? We have 1, 3, 5, 7, and 9. This in total is how many? This in total is 5 possible numbers. So you will put what? You will put 5 over here. Now the only thing you need to do is what? Is to multiply. Okay? So you have 9 possible numbers. Please excuse me one second. My bad. We have 9 possible numbers that can be placed in the first one, multiplied by 10 possible in the second one, multiplied by 10 possible in the third one, multiplied by 5 possible in the last one. So multiply everything together, 9 times 10 times 10 times 5, and you're supposed to get an answer, which is what? Which is 4,500. So we have 4,500 possible what? 4-digit odd numbers. So 4,500 possible 4-digit odd number. Okay, so that is it for question number 2. Let's move on to question number 3. How many license plates can be made using 3 distinct letters? So how many letters do they need? 1, 2, and 3. The first one can be any of the 26 letters, right? And here's the keyword, distinct. Okay, this means different. Now, if you used one of the letters in this one over here, right? then in this one over here, you will have less letters. Why? Because let's say you choose the letter W over here, okay? If I use the letter W over here, I cannot use it in the second and the third one. That means it's unavailable, or very simply, you will take it away from what? From the 26 letters. So 26 minus 1 will be left with 25. So now, for the second one, we have 25 possible letters to choose from. Now, after choosing 25, we go on to the third letter. We already have, for example, W chosen in A. Sorry, what did I say? W chosen for the first letter. And then E chosen for the second letter. And we still have one possible option for the last letter, but they cannot be W and they cannot be E. That means we have two letters that are invalid to use. If that's the case, then it's gonna be 26 minus 2, which is what? Which is 24. So in this one, we have 26 possibilities multiplied by, in the second one, we have 25 possibilities multiplied by, in the last one, we have 24 possibilities. Now, the word I was trying to write was web. Okay, so perfect. This is question number 3. Let's move on to question number 4. How many ways can a committee of 3 members, here's the keyword, 3 members, be chosen from a group of 10 students? Important. Now, here did they ask us for the number or how many students can be chosen in this? Or did they tell us how many ways? No, they told us how many ways. So when they tell us how many ways, what do? We will use the combination theorem, okay? So if they tell you how many, you will use the ways that we used for question 2 and 3. But if they tell you how many ways, okay, there's a difference between how many things and how many ways. When they tell you how many ways, you will need to use the combination. Hella, in this case, it is what? A combination of a group of 10, that means 10 is our n. And how many can be chosen? 3 members can be chosen. So this is what? This is our k, right? So here you can either put it on your calculator and you will get the answer, which is 120. Or if you don't have the option to do it on your calculator, you will have to apply this rule. nr, or nk, same thing, equals n factorial over n minus r factorial times r factorial. So in this case, what it would be 10 factorial over 10 minus 3 factorial times what? Times 3 factorial. Put it on your calculator and you're supposed to get 120. Okay, so that is it for question number 4. Let us now move on to question number 5. Now, what does it say in question number 5? Express in terms of factors. What do they mean by factors? By factors, they mean that they want it to be multiplied. So they don't want to see any factorials. They want you to write it multiplied. Let's start with A. A, we have n plus 2, 3. So this is a combination. We'll need to apply the combination rule. So it will be n plus 2 factorial over n plus 2 minus 3. This is going to be n minus 1. n minus 1 factorial times what? Times 3 factorial. Now, this n plus 2 factorial, you will need to keep on multiplying it until you reach what? Until you reach n minus 1, okay? So n plus 2, n plus 1, n minus 1, stop. It's the same over here. And then we will put what? We will put factorial. So now you can cancel this one and this one. They will go bye-bye. And you will be left with n plus 2, n plus 1 times n over what? Over 3 factorial. 3 factorial, very simply, you can do it on the calculator, or you can actually solve it, and you will get an answer of what? You will get an answer of 6. So in terms of factors, this is what it looks like. n plus 2, n plus 1, n over 6, or you could write it as 1 over 6 times n plus 2 times n plus 1 times n. Same exact thing, same exact answer. So that is it for question number 5a. Now let's do 5b. For 5b, it's gonna be what? It's gonna be n plus 1 combination, n minus 1. So now you need to do the combination. It's gonna be n plus 1 factorial over n minus 1 factorial. Sorry, my bad. Over n plus 1 minus n minus 1 factorial times what? Times n minus 1 factorial. Here, this one, after solving it, you're supposed to get 2 factorial. So this is going to be what? This is going to be 2 factorial. And then you will have n minus 1 factorial over here. Okay? Now, what do we need to do for the numerator? We will need to keep on multiplying until we reach what? Until we reach n minus 1 factorial. So n plus 1 and n minus 1, you put the factorial. You can cancel this and this. So they go bye-bye. And your final answer is going to be n plus 1 times n. My bad. N plus 1 times n over 2 factorial. 2 factorial is what it is 2 very simply because it's 2 times 1. And that's it. So our answer is what? Our answer is n plus 1 times n over 2 or 1 over 2 n plus 1 times n. Same exact thing. Alright, perfect. That's section 2.1. Let's move on to section 2.2, the binomial theorem. I think we have until question 12. Now, for question number 6, what did they tell us? Evaluate this. Now, if you have the function on the calculator, you do it. It's going to save you 50 seconds. If you don't have the function, this is how you are supposed to do it. Or if it comes in the written part, for example, this is how you're supposed to do it. First thing you're going to do is you're going to separate the sigma notation and give it to each one, or you're going to distribute it. So, sigma notation 10, m equals 1, m squared, plus sigma notation 10, m equals 1, 2m. Okay, then we do what? We do again, plus sigma notation 10, m equals 1, and then we put 1 over here. Now, anything that has a variable in it, you will take out the coefficient. What does this mean? This means it will become what? It will become sigma 1, basically, sigma notation 10, m equals 1, m squared, plus 2 sigma notation 10, m equals 1, m. This is 1 over here. Plus sigma notation 10, m equals 1, 1. Now, what do we do? Very simply, you substitute the values from 1 until 10 in m, okay? And you add, for the first part, for this one over here, what does this mean? Let me erase this now. What does this mean? This means very simply, it's going to be what? It's going to be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared plus 8 squared plus 9 squared plus 10 squared. This is all by itself, in addition to what? In addition to. So we finished from this. We can erase it. Plus 2 sigma notation 1, 10. That means you're going to substitute the values and add them from 1 till 10 instead of m. And you will multiply it all by 2. So what does this mean? Plus 2 times 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. You close the brackets. Now we finished from this. We get rid of it. Finally, last but not least, what do we have? We have this one. Whenever you don't have a variable, you only have a whole number, you can multiply n by the whole number to get the answer. So this is going to be what? This is going to be plus 10. Now add everything on the calculator. 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared plus 8 squared plus 9 squared plus 10 squared. Close the bracket, plus 2 times. Put the 2 outside of the bracket. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Close the brackets. Okay, and then finally add 10 outside of the brackets. And you're supposed to get a total answer of what? Of 505. Now this is if they did not give you any formula for m squared and m. If they did give you a formula of m squared and m, of course you will need to substitute them over here. Okay, so that's it for question number 6. Let's move on to question number 7. So, what is the term x5 in the expansion of this? Very simply, term x5. We look at our a and we look at our b. Which of them has an x? In this case, only a has an x. That means you're going to take our a, which is 3x, and we're going to put it all to the power of 5. Okay? And we're going to multiply it by 1 over 3 to the power of what? To the power of n minus 5, which is 9 minus 5, which is 4. Now, what is left? The combination. What's the combination in this case? It's n, which is 9, over k. What's k? K is 4 in this case. Now, all you need to do is to put it on the calculator. When you put it on the calculator, let me just put it. 9 combination 4 times 3 to the power of 5 times 1 over 3 to the power of 4, you're supposed to get an answer of what? Of 378 x to the power of 5. Perfect. That's for question number 7. Let's move on to question number 8. What does it state? It says, write the sixth term in the expansion in ascending powers of x. So, when they ask for the sixth term, they are not asking for x to the power of 6. No, instead, they're asking for what? For one less, so x to the power of 5. This is what they're asking us for. So basically, we need to find it x to the power of 5. We will take our a, we will take our b, we'll see which one has x. In this case, our b has x. That means it's gonna be a to the power of n minus k, and b, which is minus 2x to the power of k. We know that it has to be to the power of 5. That means k is 5, right? And how much is our n? Our n is 9. So what's left? The only thing left is to put the combination 9, 5. And you're supposed to put it on the calculator. 9 combination 5 times 1 to the power of 4. There's no necessity to put it. Times what? Times minus 2 to the power of 5. And you are supposed to get an answer of... Oh, my bad. It's not minus 2. It's plus 2. Please double check. So you see, I would have gotten a wrong answer if I didn't pay attention. Plus 2 to the power of 5. And you're going to get an answer of 4032 x to the power of 5. Now we move on from question 8 to question 9. Now let's move on to question number 9. What does it say? Obtain and simplify the coefficient of the term 1 over x squared in the expansion of this. So first thing we need to do is we don't ever like to see any x in the denominator. So we will take it up. When we take it up, it will be x to the power of minus 2. Why? It was x to the power of 2. But when you take it up from the denominator, the 2 will change into a negative 2. Or if it was x to the power of 5, the 5 will change into minus 5. Okay? Now, in the expansion of x minus 1 over x 10. This is our a, this is our b. Which one of them has x? Here, both of them have x. So in the case that both of them have x, what do? We will take their exponent, okay? And we will form an equation. What's this equation? X minus 2 is equal to x a. A is what? It's 10 minus k, right? Because 10 is our n. Or no, wait. Let's just do it n minus k. Times what? Minus 1 over x to the power of k. Whenever we see x in the denominator, we don't like to keep it, so we will change its sign to x to the power of minus 1. Okay? And now we need to solve for what? We need to solve for k, knowing that n, in our case, is how much? It is 10. Okay? So we will get rid of all of the x, okay? And what will we find? So now what do? We take the powers by themselves. Minus 2 is equal to 10 minus k minus k. Why? Because it's minus 1 times k. So minus 2 is equal to, actually no, bring 10 to the other side. You will get minus 12 is equal to minus 2k. That means k is equal to 6. Perfect. Now we have the value of k. All we need to do is substitute it. We know that k is 6. We'll erase what we crossed out and we will put 6 instead, right? Now, return everything back to normal. This is going to be what? This is going to be minus 1 over x. And this is going to be what? This is going to be 1 over x squared. Now, what did we forget as well? We forgot to put the combination. What's the combination in this case? 10 minus 6 is 4. The combination is n on top, which is 10, and then k on the bottom, which is 6. So now let's do 10 combination. Wait, hold on. 10 combination 6, you're gonna get an answer of 210 times what? Times x4 times 1 over x to the power of 6, because if it's even, it's gonna remove the negative. So now if you simplify, you're gonna get 210 times 1 over x to the power of 2. So what's the coefficient? In this case, it is 210. My bad. Let's move on to the next question, which is question number 10. Obtain and simplify the constant term. When they say constant term, that means it's x to the power of 0. Okay, we need to find x to the power of 0. Which has x? A or b or both of them? In this case, both of them have. Yani x to the power of 0 is equal to 3x to the power of n. What's n in this case? In this case, it's 8. 8 minus k times minus 1 over 3x to the power of k. Now we need to find what? Oh yeah, first thing, before we cannot leave any x in the denominator. We'll need to move it to the numerator. So it will be what? 1 times 3x to the power of minus 1. Okay, so this is all to the power of minus 1. Now, what do? We cancel out what? We cancel out the x, okay? So what is left? The exponent 0 is equal to 8 minus k. And then minus 1 times k is minus k. You will get then, bring this to the other side. Minus 8 is equal to minus 2k. That means k is equal to what? K is then equal to 4. Now that we have the value of k, we can substitute it over here. First thing, let's return everything back to normal. So it's going to be minus 1 over 3x. Okay, perfect. Now, what is left for us to do? To substitute the k with 4 and to write what? To write the combination 8 minus 4 is 4. Okay, and what is left? To write the combination. So n in this case is 8 and k in this case is how much? It is 4. Now, you need to put it on the calculator. So, what's the answer going to be? So on the calculator, do 8 combination 4. You will get an answer of 70. And then 3 to the power of 4 is 81. So 70 times 81. X to the power of 4. Okay. And then anything to the power of even, if it's negative, it will become positive. So the minus will get cancelled, or you'll remove the minus. Okay. So then times what? Times 1 over 81 x to the power of 4. Now, what do you need to do? You need to cancel. You can cancel 81 and 81, x to the power of 4 and x to the power of 4. You will get the final answer to be what? 70 times 1, which is then 70. And that's it for question number 10. We'll move on to question number 11. Yeah, I think 11 is the last of what we have. So question number 11, what does it say? It says, use the binomial theorem to find the value of 2.02 to the power of 10 correct to 2 decimal places. It's gonna take a really long time, but first thing, what do? You separate it by going from the decimal place. From the decimal place, what do you have? 2 plus, instead of the 2 put 0, 0.02 to the power of 10. Using Pascal's triangle, it's gonna take a really long time, same as using combination. So in this case, I prefer to use combination. If you want to use Pascal's triangle, you can use it, of course. Now, how are we supposed to do this? We have our A and we have our B, right? So what do? We start with, first of all, the combination. So let me make it small so that it fits. We have combination 10, 0. Then you write our A times our B plus 10, 1. A, B plus 10, 2. A, B plus 10, 3. A, B plus 10, 4. A, B plus 10, 5. A, B plus 10, 6. A, B plus 10, 7. A, B plus 10, 8. A, B plus 10, 9. A, B plus 10, 10. A and B. Of course, if you want to save time by doing Pascal's triangle instead of doing combination every time, you can do that. It's up to you as always. Now, of course, if you don't want to do it this way, you could do it in Pascal's triangle way. If you know how to do Pascal's triangle, you basically need to start from A plus B1, A plus B2, A plus B3, etc. all the way until you reach A plus B10, and then you will start 1 in the beginning, 1 in the end, then you add 2. 1 plus 2, 3, 2 plus 1, 3. And then etc. You keep on adding until you reach A plus B to the power of 10. What do these numbers represent? They represent the values of what? Of the combination. So, in my opinion, first of all, let us write the exponents of A and B. So remember, A, we always start from n and we decrease until 0. So it's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. Whereas for B, it's the opposite. We start with 0 and we keep on going until we reach n, which in this case is 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, anything to the power of 0, you remove it. which is only these two, right? Now, very important, n to the power of 0 and n to the power of n, they will both give me an answer of 1. So very simply, I can remove, did I say to the power? My bad. I mean n combination 0 is the same as n combination n, which will give us an answer of 1. So I can remove 10 combination 0 and 10 combination 10. It will save time for me, like this. Perfect. Now, all I need to do is what is multiply. Hello. I suggest first to find the value of the combination. So 10 combination what is 10? Okay, so you can remove this and replace it with 10. Then 10 combination 2, it's 45. You can remove this and replace it with the value of 45. 10 combination 3, remove it. What will you replace it with? With 120. 10 combination 4, remove it. What will you replace it with? 210. 10 combination 5, you will replace it with 252. 10 combination 6, you will replace it with 210. 10 combination 7, you will replace it with 120. 10 combination 8, you will replace it with 45. And then finally, 10 combination 9, you can replace it with 10. So now let me erase the top so we can have a space to write our answers. Let's start first of all with 2 to the power of 10. What's 2 to the power of 10? It's 1024. Plus, now what do? We do 10 times 2 to the power of 9, right? Times what? Times 0.02 to the power of 1. What will you get? You will get 102.4 plus. So we finish from this one. We also finish from this one. Plus now, 45 times 2 to the power of 8 times 0.02 to the power of 2. What will you get? You will get 4.608. Okay, we finished from this one. We move on to the next one. So it's gonna be 120 times 2 to the power of 7 times 0.02 to the power of 3, and we'll get an answer of 0.12. This is 0, by the way. Let me fix it. 0.12288. So we finished from this one. We can erase it. Let's move on to the next one. Plus 210 times 2 to the power of 6 times 0.02 to the power of 4. So we will get an answer which is what? Which is 0.0021. Wait, sorry, my bad. 0.0021504. Now, here we stop. Why do we stop? Because they said correct the 2 decimal places. And for this one, where does the number start? The number starts on the 3rd decimal place. So when the number starts at a decimal place after the one that they want, so if they said, for example, 4th decimal place, you will need to find the value where it stops at the 5th one. Here in this case, they said to the 2nd decimal place. So we found a value that is in the 3rd one. Okay, so it stops at the 3rd decimal place. That means you don't need to finish the rest. Okay. The rest were just for decoration. Okay, you don't need to finish the rest. Now you can do what? You can add everything together. So it's 1024 plus 102.4 plus 4.608 plus 0.12288 plus 0.0021504. So you will click on equal, and to 2 decimal places, what will we get? We will get 1131.13. So this is the final answer to 2 decimal places. Now, last but not least, the final question. Expand as far as the term in x to the power of 3. So look what we will do over here. We have a trinomial. What we can do is we can separate them into a and b. Perfect, right? Let's first start with, let's do a Pascal triangle. We have a plus b to the power of 3. You guys should know that it's 1, 3, 3, 1, or you can find it. Then a plus b to the power of 4. We need to find it. 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4. So now there is no need to do combination. Why? Because we already have the value of the combinations, which are 1, 4, 6, 4, and 1. Perfect. Now we have the value of the combination. Now, what do? We'll replace a and b plus a and b plus a and b plus a and b. This is squared, my bad. plus a and what? And b. Okay? Sorry, the squared goes inside. The squared is with the x. It's part of the x. Now, what do? We start by n for a. We always start with n and we decrease. So 4, 3, 2, 1, 0. For b, we do the opposite. We start with 0 and we increase all the way till n. So 0, 1, 2, 3, 4. Now, anything to the power of 0, we can remove it. 1, we can also remove it if it's multiplied only. And we are now left with this. So can you write it down on your copybook, because I kind of need some space in order to solve the rest. So I'll write it on my copybook. 1 plus x to the power of 4 plus 4 times 1 plus x to the power of 3 times minus x squared to the power of 1 plus 6 times 1 plus x to the power of 2 times minus x squared to the power of 2 plus 4 times 1 plus x to the power of 1 times minus x squared to the power of 3, and then plus minus x squared to the power of 4. Please write it down because we need it to continue solving. All right? So now, for the first value, which is what? Which is 1 plus x to the power of 4. Again, we can use Pascal's triangle. We know the values 1, 4, 6, 4, and 1. Okay, let me just put the 1 over here. Now, what do? We have our a and we have our b. We will substitute a, b, plus a, b, plus a, b, plus a, b, plus a, b. Now what do we do for the exponents? With a, we start from n and we decrease until 0. So 4, 3, 2, 1, 0. For b, we start with the 0 and we increase until n. So 0, 1. I think I put the 2 here. It's supposed to be here. 2, 3, and 4. Now, anything to the power of 0, we can remove it. 1, if it's multiplied, we can remove it. Okay, so this is what it's supposed to look like. What will we get? We will get 1 to the power of 4, which is 1, plus 4 times 1 to the power of 3 times x, so plus 4x, okay, plus 6x squared, plus 4x to the power of 3, plus x to the power of 4. Okay, so this is what? This is 1 plus 4 to the power of 4. Now, sorry, my bad. 1 plus x to the power of 4. Now, again, on your copybook, write 1 plus x to the power of 4. Arrow, it is what? It is 1 plus 4x plus 6x squared plus 4x to the power of 3 plus x to the power of 4. We're going to need it for the later use. Now we finished the first term. What was the second term? Second term for us was 4 times 1 plus x to the power of 3 times minus x squared to the power of 1. Now, 1 plus x to the power of 3, we know the values of the combination. They are 1, 3, 3, 1, right? So, we'll write AB plus AB plus AB plus A, this is 1, B. Now what do? We put for them the exponent. You will start with n for A and decrease until 0, so 3, 2, and 1 and 0, okay? And then for x or b in this case, you will start with the 0 and you will increase until n, so 0, 1, 2, 3. Anything to the power of 0 or multiplied by 1, you can remove the multiplied by 1. Okay, I don't know what happened. Let me just... hold on. Okay, if you can still see, it's fine. So this is what it looks like. 1 to the power of anything is 1 itself, so there's really no need to put it to the power of anything. We only keep this one because it's added, not multiplied. So now, let us see how we can solve this. This will become 1 plus 3x plus 3x squared plus x to the power of 3. Now, only thing is we need to multiply it by what? We need to multiply it by minus 4x to the power of 2. So let us multiply it by minus 4x to the power of 2. What will we get? We will get minus 4x squared minus 12x to the power of 3 minus 12x to the power of 4 minus 4x to the power of 5. Perfect. Now, we move on to the next one. So please, first of all, before we move on to the next one, write on your copybook 4 times 1 plus x to the power of 3 times minus x squared will give us an answer of what? Will give us an answer of minus 4x squared minus 12x to the power of 3 minus 12x to the power of 4 minus 4x to the power of 5. Now we'll move on to the next one. What is the next one? The next one is 6 times 1 plus x squared times minus x squared to the power of 2. Let us start. First of all, with this, it's gonna be what? It's gonna be 1 squared, which is 1, plus 2 times 1 times x, plus x squared, okay? Times what? Times 6 times minus x squared to the power of 2. Anything to the power of even, you will remove the minus, okay? So basically, it's now x to the power of 4. So now we need to multiply. Let us multiply. It's gonna be x to the power of 4, sorry, 6x to the power of 4 plus 12x to the power of 5 plus 6x to the power of 6. Do we take this? No. We do not take it. Why? Because they want as far as the term x to the power of 3. And the smallest term is x to the power of 4. That means starting from this one, everything else is going to be unnecessary. So what do we keep for us? We keep for us the term 1 plus x to the power of 4 plus 4 times 1 plus x to the power of 3 times minus x squared. Okay? So what is the value of 1 plus x to the power of 4? It is 1 plus 4x plus 6x squared plus 4x to the power of 3 plus x to the power of 4. Do we need x to the power of 4? No. Why? Because it's to maximum the term x to the power of 3. Now, plus, how much was all of this? All of this was minus 4x squared minus 12x to the power of 3. Do we take minus 12x to the power of 4 minus 4x to the power of 5? No. Why? Because they want maximum x to the power of 3. So we only need to add them now. So it's going to be 1 plus 4x plus 2x squared minus 8x to the power of 3. So this is our final answer for question number 12. And that is it for this video. Thank you guys for watching. I hope you enjoyed and have a wonderful day.